Hello and welcome to another episode of Let's Make It. This is episode number 11, and this week we're going to talk about keypads and inputting keypads into an Arduino. However, before I start, I do want to send out kind of a shout out and an apology at the same time to Dennis Englander. Hopefully I said his name correctly. I got an email from him this week and I haven't had a chance to reply, so that's my apology. In Dennis's email, he's been watching the show and he's talking about maybe even using some of the Arduino stuff on model railroads. So I'm very curious how and what he does with that. And Dennis, if you do something like that, get something working, please send us a video. We love the feedback. The more feedback, the better. And again, apologies for not getting back to you quicker than this. All right, so this week I mentioned we're going to talk about keypads on an Arduino. And one of the first things I want to do is I wanted to show you what we're working with because it does look a little bit like a mess. So don't be too scared when you see this. This is the Arduino this week. And what we have is we have a serial display that we talked about before. So we're using the same libraries that we did in the previous show. And right here you can barely see them. There's a red and a green LED, which will be used in the second project, or second sketch that we talk about. And then here's this little keypad, and it's very light. And you'll see when I let go of it, it just wants to fling back to wherever it was. So it's something I have to hold when I use it, and I'll show it to you. But it's very thin. It's just a little membrane. You can see how thin it is. It's a little membrane keyboard. And I want to talk a little about these keyboards. So you'll notice on the bottom there is 8 wires, and the keyboard is a 4x4 keyboard. So the way these work is these little runs that are down here in this cable. Each one, 4 of them go to these rows, and the other 4 go to these columns. When you press one of these numbers, 2 of these pins get connected together. So what's happening in the Arduino, and I'm going to talk about the library that's doing this a little bit, but what's happening in the Arduino is it's random, or not random, it's serially going through 4 of these pins, making them high really fast, like around in a circle. So maybe doing, I don't know exactly which way it's doing it. I don't know if it's doing it by row or by column, but it's basically saying, you know, this row is hot, or has a high, 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 and high. And when you press this, the high goes back down the other side, and it looks for that. So it's basically scanning, looking for what's been pressed. So that's the 8 pins, 4 for each row, and 4 for each column. And then that comes back into the Arduino. And the way I have it set up in the Arduino is I'm starting with pin number, let's see, 3, 4, it'd be pin 5, and it goes to pin 11. That's the 8 pins that I'm using. And right now I'm running a sketch that basically all it's doing is going to show you what button I press. So I'm going to press button 8. You see it says 8. I'm going to press 6. It says 6. And I can press any, I can do C or A or whatever. Any of these buttons are going to come up and show you what button I actually pressed. So what I want to do first is walk through this because, again, this is a library that was taken from the Arduino website. It's under code projects, I believe. I have a link in the actual program itself, as well as the show notes that will be in there as well. And it helps a lot with this. If you could do it yourself, and actually, I'm tempted to write a program using the Arduino, just in regular Arduino language, not the C classes, to show you how simple it really is to use one of these. But the library makes it very quick and simple. So what I want to do is get over here to, let me get out of this, and bring up the Arduino program and go to the computer. And there we see the Arduino program. And this is the keypad input that we were just looking at. And this is a very simple program to understand. So let's get down past my header information. So the first 2 things you see right here is I'm including wire.h and liquid crystal.h, and this is just for the display. We talked about this, I believe, it's episode 6, and I'm not going to go over in great detail how the 2-wire interface to the LCD works. The reason I used the 2-wire interface is because I was using so many pins with the keypad. I wouldn't have been able to use a parallel screen with all the pins that are required. So the next thing that's new is this keypad.h, and this is the library that I downloaded. And let's scroll back up here a little bit. And right here you see the link to the library. So if you go to this link, it's playground code. You go to arduino.cc/playground/code/keypad, and you can download this exact library that I'm using. So that's the quickest way to get this started. but that's what keypad.h includes. Now, to define the actual keypad, you could do this a couple different ways. I thought this was probably the simplest way to do this, was I defined the number of rows and the number of columns, which are both 4 in my case. You can get them into 3x4s, so they don't have like the A, B, C, and D down the side. So it really depends on which keypad you're using. Then you define a multi-dimensional array. Basically, it's 2 dimensions, one with row and one with columns. And you define what is at each position on each keypad. So you see my keypad, and let's go look at the keypad again real quick. You can see the keypad is 1, 2, 3, A, and then 4, 5, 6, B, 7, 8, 9, C, and then star 0, pound, and then D. So if you look at the code, I have defined it exactly the same way. 1, 2, 3, A, 4, 5, 6, B, 7, 8, 9, C, star 0, pound, D. Okay, so that defines the keyboard, and basically it's an array. So I can say, based on this position, I know when I get that back, it's been a 5. So now what I have to do is define what each of the pins is connected to. Now this actually threw me for a loop, because I didn't have a schematic for this particular keypad, and I had it backwards. Basically, I had everything backward. I had what I thought was rows and columns based on another keypad that I had, and then it's the reverse I had correct, but I had them like this 11, 10, 9, 8 was down at the bottom, and then the 7, 6, 5, 4 was at the top. So this keypad that I'm using, this is how we have to have it configured. So pin 11, 10, 9, and 8 are for each of the rows, and the pin 11 is the top row, pin 10 is the second row, and so on. And then pin 7 is the leftmost column, and the 4 is the rightmost column. So after we define the pins, we have everything we need to actually create the class. So what we do is we define a variable. I'm calling it keypad just to keep it simple so we know what we're looking at. And it's a keypad type, class type, and then I'm defining the instant of the class as being this make key map, and I give it the keys, so it's making a key map from this array and sending that over to this keypad library. I'm telling it how many, or telling it which pins are for the rows and which pins are for the columns, and then the number of rows and number of columns. Now I could have obviously made rows and columns in here 4 and 4, and I could have put that right here 4 and 4, and I could have put 4 and 4 here. But by making it a variable, if I want to change my keyboard, I can easily do it. I can go to a 3 to 4. So if I only have 3 columns, I can just take and change this right here to 3, and everything follows on. I actually have to get rid of this column right here too in the process, but I wouldn't have to go through everywhere and make sure I got it. So that's why I'm using variables. Then you see me define liquid crystal, which we talked about again in episode 6. If you have questions about that, go watch episode 6. We covered the LCD, the serial LCD, in pretty good detail there. Then we come back and we're in the setup. So we do our initial LCD setup. We turn our backlight on. I'm basically setting the cursor to position through row 1, position 4, and typing out the word "you pressed:", which we saw on the screen. We'll go back and look at that again. And then all I'm doing at this point, and this is the end of the program, as very simple, is I'm reading keypad input by doing keypad.getKey. Now here's the thing, and this library returns a 0 or nothing, basically null, if no key is pressed. So what I'm doing here is I'm saying if the value of the key that was pressed is not equal to 0, which means something was pressed, then I want to put my cursor at position 17 on the first row, and I want to print out what that key was that was pressed. However, if nothing's being pressed, I don't want to do anything, because here's what's happening, and this actually happened to me, and it was confusing to me when I first did it, is I didn't have this if statement in here. I was just doing set cursor print, and when I'm not pressing a key, it comes back as null. Well, that prints a weird character on the screen, and so as soon as I pressed it one time, I would see it blink and go back to the weird character. So I had to put this code in here to look for a key press. I was not aware until I started messing with it that it would return null like it was. And if you hit the button one time, it does not keep. It returns nulls in between. Eventually, we'll come back and it will tell you the key is still being pressed. So that's how simple this little program is. And now all it does, and let's go back again and look at the actual Arduino. And get the keypad here. And you see on the screen right there, it says you pressed, and the last thing I pressed was star. So I'm going to press 8. You see it says 8, and then there's 5, and there's 2. Right there's 2. So you see, it's all that program is doing is just showing you what input was pressed. Now that was pretty much what I was going to cover for the evening. However, about a half hour ago, I got this wild hair and decided I wanted to make something a little bit more. So I was going to basically bring the Arduino in with the keypad and the LCD and show you how to do keyboard input and how simple it was. And that was going to be my show. So that would have been like 11 minutes of a show. And I just didn't feel right doing an 11-minute show. So I have since gone and created a program or a sketch, and I'm going to load it up here in a second, and we're going to walk through and play with it. That basically simulates entering a numeric code to get into a door. And actually, this could be used for that. I'm using LEDs to distinguish if it's open or closed, but those could easily be set up to be on a relay for a door, or anything like that. So just as an example, so let me go over and get into that. And I'm going to load it up. Okay, the sketch is uploading. All right, and it's done. So let me go over to the Arduino. Oops, Arduino. And, oh, still booting. So here's our keypad. Now I'm going to tell you right now, our code is 1, 2, 3, 4. So if I enter in my code, 1, 2, 3, and 4, you see the green light comes on and it says access granted, welcome. But let's say I put in 1, 2, 3, A. All right, that's an invalid code. Let's say I put in, well, it's still, there we go. Let's say I put in 1, 4. Oh, invalid code. Maybe, let's see. Let's try 5. Oh, invalid code. So you see it immediately tells me invalid code. You see the red light come on, invalid code, and it tells me on the screen invalid code. And when I put in a valid code, I see the green light, which is where you'd open a relay or whatever to open a door, and you see on the display screen, access granted. So what I want to do is I want to walk through this program. It's a little more complicated than the other one, just because it's a little bit of a state table, which we've talked about in previous episodes as well, about how state tables work. That was the one where we talked about stoplights. And there is a sort of state table in this one as well. Basically, it's a state table that keeps track of what input number you're on to check your passcode. So let's go hop over to the computer and we're going to walk through this code. Okay, on this code, it's called secret key code. We're using the same library. You see right here, the keypad library, and I had the link in the header there too. And at the top, we're very similar. We have the LCD stuff. We're not going to talk about that in detail. Again, that's episode 6. If you want to go watch that. And then we have keypad H, which we had in the previous sketch as well. And then we get into a little bit more. So I have set up constants for the green and red LEDs. Again, that's just for consistency through the code. You can easily modify them by just changing these variables, and it would follow through the code. Next, you see me setting our secret code. Now I'm just using 1, 2, 3, 4. It could be 1, 2, 3, A, or any of the keys that are on the valid keypad, including star or pound. And then I'm defining a variable current position. This is part of the state table that we just mentioned. Basically, this is going to hold the current location of the key press that you're entering. So you start out at the very first one. So you're going to be looking for the key press of 1. And if you don't get it, you're obviously putting in the wrong code. And then if you get 1, then current position will add by 1, and it's looking for a 2. So that's just how we do our state table as to where we are. And you'll see that more on down in the code. All right, now we get back into the defining of the keypad, which is exactly the same as the first sketch. It's 4 by 4. It's the exact same keypad. So everything here was pretty much just copied right out of the other program. So let's come on down, and in the setup, things are a little bit different. So here's basically you have the LCD in it like we had before, and you have the turn the backlight on, the all standard stuff. But then I'm going to display the screen that you are sitting at by default, which is the let's make it, and let's go look at this. So we're going to see how this is all working. It's this screen right here. It says let's make it secret code project, enter secret code. So let's go back and look at what this subroutine does. So I'm going to call display code entry screen. So let's go find that down here. All right, here it is, display code entry screen. And the first thing I do is clear screen. Now, there's probably a more proper way to do this, but because I only had 20 to 30 minutes to write this, I did it the old-fashioned clunky, what I would consider clunky way, which is I set a cursor and I blank out each of the lines. It's probably not the most efficient, but for an example for this, it's going to work. There is probably a screen blank code. I just did not have a chance to go look up what it was. So I just did it the quick and dirty way. So back to our display code entry screen. Here is the clear screen. I'm going to set my cursor to the first position of the first line, and I'm going to put out, let's make it secret. Go to the second line, code project, and then go to the third line, enter secret code. So that's the display code entry screen, and that's just part of my setup. So I just displayed it on the screen. Now I'm going to go to the red and green LED pins, make sure that they're output, and turn them both off. All right, so that's done the setup, and now we start our loop. So here is our loop, and I'm going to define an L, and L for me always means loop, and you'll see that in the for loop down here, how I'm going to use that. I'm also, now, this should actually probably be on like this, because I'm going to take the key input from keypad get key, and if it's being pressed, which means it's not equal to 0, I am going to first of all blank out an area on the screen, and you'll see in a second what this does, and I'll show you how this works. But this area of the display, which is the fourth line starting at the 14th position, is going to be blanked out, and then I go back to that same position. And then here, what I'm going to do is put out an asterisk for every character that has been pressed. So this simulates how many characters have been pressed. On the first program, I was actually telling you or showing you which key was pressed, but you wouldn't want to do that in a secret code. It'd be like any password. So what I'm doing here is just showing you that, yes, I saw your key press. If I didn't do this, you could press a key and you could be wondering, did it take it or did it not take it? This is how I'm getting around that. The other option, and how I did it originally, was I just did this LCD print for each time you pressed a character, and it would just add to the end of it. The problem is it doesn't always clear properly. So this allows me to make sure that what you're seeing is the exact number of characters that are actually there. This is probably the better way. It just didn't work reliably the way I had it before. Okay, so now we come down and since we have a valid key, we're still in this routine. I printed the asterisk out saying I saw your keyboard press. Now I say, is that keyboard press equal to our secret code at our current position? So here's that state table variable again. So I'm starting out with 0. So in our case, our code is 1, 2, 3, 4. If the key that was pressed was equal to 1, which is the first character of our secret code, then I'm going to say, okay, my current position is now number 2 because the first one was valid. And then I'm going to come down and I'm going to compare the current position to equal to 4. And if it's equal to 4, that means that I got all 4 of the valid code. So at that point, I can do unlock door and start over again at current position equals to 0. So let's go look at the unlock door at this point. We're going to scroll down here, and here is the unlock door routine. So what am I going to do? I'm going to turn on the green LED saying that you got access. I'm going to clear the screen. I'm going to set the cursor to the very first line, the first position, put out a row of asterisks. And then I'm going to go to the second row and put out access granted. I'm going to go to the third row and say welcome. And I'm going to go to the fourth row and put out asterisks. So let's go look at what this looks like on the actual Arduino itself. Okay, so on the Arduino, here is the keypad again, and I'm going to enter a valid code. Now, as I do this, we'll watch down here at the bottom right here, and you're going to see asterisks. 1 asterisk, 2 asterisk, that's because I'm in position number 2. Third asterisk, and here comes the right code, 4. So there you see the green light comes on, access granted, so it did the whole clear screen, printed this out, and after 5 seconds, it clears screens and goes back to the beginning and turns off the green LED. So let's go back over here to the computer. So right here, we saw us turn the green LED on. I cleared the screen, which happens fast enough you couldn't see it. And then I printed this out saying access granted, welcome. I waited 5 seconds, turned the green LED back off again, And then I redisplay the code entry screen because now I'm back to the point where I'm ready to take another input. So that's what unlock a door does. Let's go back up to here now. So we left here, and now when we come back from unlock door, I'm starting over again. So I'm seeing my current position is equal to 0. Our state table is now equal to 0. And I'm going back through my loop again. So I'm going to go through that whole loop over again. But let's go through this time and say we get to position number 1, which is actually number 2, basically, second position. And somebody enters a different something other than 2. And I'm going to say, let's say they enter 5. It's, whatever it is, it's not going to match. So our key is not going to equal to our current position of our secret code. It's going to come down here and it's going to do invalid code. Let's go look at invalid code. And it's right here. And right here, I am turning the red LED on. I'm going to clear my screen, print out the same row of asterisks, write out access denied, invalid code, and then a row of asterisks. I'm going to wait 5 seconds, turn off the red LED, and then put back the code entry screen one more time. Go back and start from the beginning. And then I come back and I say current position equals 0 because obviously if they entered an invalid code, I don't want them to keep trying that same code because there's only, in this case, 16 keys. If I didn't go back to the beginning, they could re-enter the code again and keep pressing each of the buttons till they find out what it is. So I want them to have to start over again. So that's current position. And then when I do that, we're back to the beginning and we're starting from the very first character all over again. Now, I put some code down in here in this unlock door, and it's right here, and it's this comment. So let's say you wanted to unlock a door. You could actually use the green LED pin instead of turning on a green LED and go out and control a relay of some sort that would open your door. And typically 5 seconds on a door relay is enough to let somebody in. So that can be easily done. You could also add in here an additional line. I don't have any more pins on this particular Arduino, but, well, actually I do. That's not exactly true because I do have the analog out pins I could use. But you could come in here and put an additional line that would turn on another pin that would do the same thing. So you could use both the LED and something to open a relay. You could also, and this is something that I'm probably going to work on here next week or the week after, is servos. So you could actually have a servo do something. And if you had a small enough item that the servo was powerful enough to actually move the pin to open the door, you could actually have the servo open itself up and let somebody open the door up. And you can get some pretty good sized servos. So that's not a far-fetched option. It's probably a little bit more expensive and a little more elaborate than the typical relay and for the door lock, but either one would work just fine. All right, so that is pretty much, that's still a very short show. That's still only 20-some minutes. So again, a very short show this week, although it would have been very short if I didn't extend this a little bit by adding this other program. This will all be up on the show notes at techzen.tv, or you can go to letsmakeit.tv. That'll take you right to the right page inside of the TechZen TV website. Either way will get you there. And this will be episode number 11. I'll put all the show notes up there and links to everything. I probably won't have links to the display or anything because that was all in a previous episode. Again, episode 6 was the LCD. I don't remember what episode was the state table. I think it might have been 8 or 9, episode 8 or 9. And it's the one about stoplights that talks about state tables where we actually build, stoplights with car waiting sensors and stuff like that. I love the feedback. As I mentioned at the beginning of the show, I got some feedback this week I didn't have a chance to answer yet. I will get to that very soon. But if you're making something, you're getting parts and you're starting to play with this, make us a video and send it to us. We'd love to see that. We're truly trying hard to build a community around all of our shows. And the best way to do that is to get people to give us feedback and send us your examples of things you make. Also, I would like to have feedback as what you would like us to show you. I'm just going at this point showing you things that I think are interesting. And my first 9 or 10 episodes really was focused on getting you used to the Arduino and the language and just getting the basics in there. But now I'm getting to the point where I could go a couple different directions, and I kind of want some direction from our viewers as to what you would like us to show you. I actually have some Raspberry Pi projects coming up here. The other project I mentioned, like on my first or second show, I'm ready to start working with that a little bit more. and showing you how to do some wireless, like with Zigbee. So, I mean, a couple of things like that. Next week I said about servos. There's a couple different things that I still can do that I have planned before I would leave the Arduino, but I don't mind sticking with the Arduino a little bit longer if you have something that you want to see or you want to learn. And I love the feedback to kind of set that direction a little bit. And again, we're trying to build a community, so if you're watching us like on YouTube, you hit the subscribe button. That helps us a lot. Tell your friends about it. Hit the like button. Things like that. Just to help get the word around so we can keep building the community. If you're watching us like on iTunes or something like that, there's subscribe there too, and that's actually a great way to get us because it's completely automatic. It'll download to all your devices, your iPhone, your iPads, whatever, and you can download it and watch it on your time. And I think that's part of our whole slogan is technology on your time, and that's kind of how we like to do it. We do like people being in the chat room. Now tonight I'm here in the chat room all by myself, and it's a little lonely in the chat room right now, and would love to have you come and watch us live every Tuesday night at 7 p.m. Today I got started a little bit late. The stream came up about 7:05 because I had some problems with the stream, but I didn't get started about 7:20. But the pre-show stuff, if somebody's here, I'll answer questions and talk to them before and after the show, both in live chat. We also have a ton of other shows. We have a new one just came out that we think is really going to catch on. It's actually a fan-based show. It's the first one of these we've done, so it's a little bit of an experiment for us, but it's about American Idol and American Idol fans and what do they think about how America voted and who they like, things like that. So it's a very fun thing. It's also very interactive. We invite people in via Google Hangout to come in via video and talk with us what they think. And that's on Thursday nights, about a half hour before the results show we start. Talk about the shows of the week and what people thought about the performances. We don't do a lot through the results show. We talk during the commercials, just do recaps. But then afterward, we talk again and see what people thought about the results. Do they think America got it right? Or why do they think they got it wrong? Things like that. So it's a very different kind of show for us. Not very technical, more fun. And but we have all kinds of technical shows, too. If you're into security, we have Security 101 for people who are new to computers or aren't really internet security savvy. We have Security Coded, which is for security professionals and IT professionals. We have a Mac show to show you how to get used to the Mac if you're moving to a Mac from a PC. So we have all kinds of things like that, and we'd love input for new shows. And again, spread that around. We're trying to build a community for all of our users, and we'd love to have the community start to grow a little bit faster than what it's been. So if you see a show and you like it on YouTube, click the like button. That definitely helps us out and help get the word around. So we definitely appreciate that. That is it for Let's Make It this week. Again, feedback for future shows. Love to have it, and the sooner the better, so I can research things I don't know. It's always good to be a little bit more prepared when you get to a show. Like I said, next week it's either going to be Zigbee on wireless or it's going to be servos. One of those two for next week. And we'll see you next week.